Hello dear students, chapter quadrilateral exercise 7.1 question number 4. Show that diagonals of a square are equal and bisects each other at a right angle. What we have to show here? Diagonals of a square. So for that we need a square and we have to show that diagonals of a square are equal and bisects each other. For example, if we have a square AB, C, D and diagonals are intersecting at O. What we have to show here? Show that diagonals of a square are equal. That is, first thing, AC is equals to BD are equal. First thing what we have to prove. And second thing, and bisects each other. Bisects each other. Second thing what we have to prove is bisect in the sense OA is equals to OC. OA is equals to OC and OB is equals to OD. Bisects each other at right angles. So where they bisect, they form an right angle. Right angle. That is, third thing what we have to prove is angle AOB is equals to angle BOC is equals to angle COD is equals to angle DOA. DOA. All the angles are equals to 90 degree. This thing we have to prove. These all are to be proved. Okay. First, let us start the solution. What is required for the fourth question? Consider a square ABCD. Consider a square ABCD. Comma AC and BD are diagonals. So when we say it is a square, what we have? We have AB is equals to BC, means all the four sides are equal. CD is equals to DA. Let this be equation 1. And when it is a square, we know that opposite sides are parallel. AB is parallel to CD and BC is parallel to AD. Let this be equation 2. These two things we have. Now let us prove one by one. First thing, we have to prove that diagonals are equal. To prove first one is diagonals are equal. Diagonals are equal. Look at the figure here. What we have? To prove diagonals are equal, let us consider the triangle ADC. Okay. A D C and triangle B D C, ACD BDC. Let us take these two triangles. What triangles we are considering? Triangle A C D and triangle B C and D. These two triangles we are considering to prove diagonals are equal. So, in triangle A C D and triangle B D C, ACD BDC. Let us consider these two triangles here. To prove what we have to prove here, to prove diagonals are equal. So first thing, as it is a square, we know that AD is AD is equals to BC. Why? Sides of a square. That is, we are already having in equation 1. From equation 1. Second thing, angle ADC. Look at here. Second, angle ADC is equals to angle BCD. BCD is equals to how much? 90 degree. Why they are equal? Yes, angles of a square measures 90 degree. Next thing is CD is equals to CD is equals to CD. It is a common side for both the triangles. So therefore what we have here, side, angle, side. From side, angle, side, congruency, triangle, which triangles? Triangle ACD, triangle BDC are congruent. Triangle ACD and triangle BDC are triangle CD is congruent to triangle BDC. When these two triangles are congruent, now we can easily write that. What you can write? Diagonal AC and BD are equal because of CP CT. Therefore, AC is equals to BD, that is CP CT. First thing, diagonals are equal, we have proved here. Okay, now let us prove second thing. What we have to prove in this? We have to prove diagonal bisects each other. This one, diagonal bisects. We prove diagonals are equal. Now we have to prove diagonal bisects each other. That is, OA is equals to OC and OB is equals to OD. Next thing, what we have to prove is diagonals diagonals bisect each other. So that is OA is equals to OC and OB is equals to OD. We have to prove this. So to prove this, what triangles let us take from the above figure? Let us take triangle. So we have a triangle, that is triangle. We have a square A, B, C, D. From this square A, B, C, D, now I will consider only triangle A, O, B and C, O, D. Now, in triangle A, O, B and triangle C, O, D. Look at here, students. What we have to prove here? OA is equals to OC and OB is equals to OD. We have to prove here. Here we can prove in different methods, two different methods, but here we will go with one thing. We know already ABCD is a square, right? So AB is equals to CD. We have that. And one more thing we have, alternate interior angles are equal, right? So using these things we can prove it. So first thing, what we can take, angle ABO, angle ABO is equals to angle CDO, is equals to angle CDO, alternate interior angles. Why? They are equal and they are opposite and parallel in square. Second thing, AB is equals to CD. Equation 1, we have this in equation 1. Sides of a square are equal. Next thing is one more alternate interior angle, BAO, angle BAO is equals to angle BAO is equals to angle DCO, DCO, that is also alternate interior angles. Therefore, from side angle side congruency, triangle AOB is congruent to triangle COD. When these two triangles are congruent, now we can say that OA is equals to OC and OB is equals to OD. CPCT. OA is equals to OC and OB is equals to OD, that is of CPCT. So we named already how many equations? I think two equations we named. Let us name this as equation 3. So last thing in this, what we have to prove is every angle is they bisect at 90 degree. We have to prove this. Okay. For that, let us consider triangle ABCD. BO and triangle BCO, or you can tell AOB and triangle BOC. These two triangles we will consider, and we prove that diagonals intersect making an angle of 90°. Third thing to prove, diagonals intersect each other at 90°. So in triangle AOB and triangle BOC, in triangle AOB and BOC, we already have AB is equals to BC, because these two are sides of a square, right? And just now we proved AO is equals to OC, right? Next, OB is equals to OB, all using side criteria. See, AB is equals to BC, sides of square, right? Sides of square, right? Completely. Next thing, OA is equals to OC. We have proved this in equation 3 we have above. Next thing, OB is equals to OB, which is a common side for both the triangles. Therefore, from side congruency, triangle AOB is congruent to triangle BOC. So when these two triangles are congruent now, because of CPCT, you can write angle AOB, you can write angle AOB is equals to angle BOC. CPCT it is, right? Therefore, angle AOB is equals to angle BOC, CPCT. But what we have to prove, all the angles are 90°. Angle AOB plus angle BOC is equals to 180°. Why? Linear pair angle. See the figure. AOB, BOC. Sum of these two angles is equals to AOC. These two are linear pair angles, isn't it? So, but in equation 3, we have angle AOB 3 or just we solved, right? Here we solved above. So, in above equation we have angle AOB is equals to BOC. Therefore, I can write angle AOB plus angle, instead of BOC I can write again AOB, because those two are same, is equals to 180°. AOB plus AOB 2AOB, which is equals to 180°. 2 ones are 290. AOB is equals to 90°. Therefore, angle AOB is equals to angle BOC is equals to 90°. Angle AOB is equals to angle COD is equals to 90°. These two are vertically opposite angles. Similarly, angle BOC is equals to angle hmm, DOA is equals to 90-degree vertically opposite angles. So all the one by one we have proved it. Okay. Question is easy but bit lengthy. No. Understood, right? Fifth. Fifth question. Show that the diagonals of a quadrilateral are equal and bisect each other at right angle, then it is a square. Show that the diagonals of a quadrilateral, we are given with a quadrilateral. Diagonals of a quadrilateral are equal. First thing what they are giving us, the diagonals are already equal and bisects each other at right angle. They are bisecting where making an 90-degree right angle. We have to prove the above figure ABCD is a square. Okay. So let ABCD be the quadrilateral quadrilateral. What is given to us? Given AC is equals to BD, that is diagonals are equal. This is given to us. Next, they bisects each other. They bisects each other means OA is equals to OC and OB is equals to OD. It is also given to us. And they bisects each other at 90-degree. Angle AOB is equals to angle BOC is equals to angle COD is equals to angle DOA. All are is equals to 90-degree. Let this be equation 3. These all are given to us. What we need to prove? To prove ABCD is a square. So what are the properties of a square? We have a quadrilateral here. Many things are given to us. What is not given? To prove AB is equals to BC is equals to CD is equals to DA. If we prove this and angle A is equals to angle B is equals to angle C is equals to angle D is equals to 90-degree. If we prove these two, then it is a square. Okay. So first, let us try to prove the sides are equal. Proof. So in the above figure, we have a quadrilateral ABCD. First, let us consider these two triangles, triangle AOB and triangle COD. In triangle AOB and triangle COD, these two triangles we are considering. So already we have OA is OA is equals to OC. It is given to us, right? Because diagonal bisects each other. Given, right? It has given clearly. Next, angle AOB is equals to angle COD, because these two are vertically opposite angles. Next, OB is equals to OD. OB is equals to OD because it is also given to us. So therefore, from side angle side congruency, triangle AOB is congruent to triangle COD. When these two are congruent, we can say that AB is equals to CD. AB is equals to CD because of CPCD. Similarly, students, consider triangle COB and triangle AOD and prove AD is equals to CB. Similarly, we can prove AD is equals to BC. Okay, when the both the opposite side pair of opposite sides are equal, then what ABCD is? Now ABCD is a parallelogram. Okay, ABCD is a parallelogram because we got AB is equals to CD and AD is equals to BC we got here. So ABCD forms a parallelogram. Now in triangle ACD, what we have to prove next? We have to prove any of the angle is equals to 90° to make it a square. Now we have all the sides are equal. All the sides are equal we have here. Now what we have to prove? It is a square we have to prove. To prove one of the angle, we have to prove it as a 90°. Dear students, before proving 90°, one more thing we have to prove here. That is, we have proved ABCD. We have proved AB is equals to CD and we have proved AD is equals to BC. One more thing what we have to prove is AB is equals to BC. If we prove that, from this we can say that all the four sides are equal. So how to prove this? I will leave this proof to you people here. That is, proof AB is equals to CD. Sorry, AB is equals to BC. How you will prove is, consider these two triangles AOB and BOC. Okay, we have OA is equals to OC. We have OA is equals to OC. We have angle AOB is equals to 90° and BOC is equals to 90°. We have this also, and then OB is equals to OB. So these two triangles are congruent. You can say AB is equals to BC. I will leave this proof to you people. After this, now I have to prove any of the angle as 90°. So in triangle ACD and triangle BDC and triangle BDC, AD is equals to BC. First thing, AD is equals to BC. AD is equals to BC, and AC is equals to BD. Diagonals are equal. Diagonals are equal. Already we have. Next, BD is equals to, sorry, DC is equals to DC, common side. So from side congruency, triangle ACD is congruent to triangle BDC. When these two triangles are congruent, we can say that angle ADC is equals to angle BCD, CPCT. Now we got these two as equal angles. Okay. So now AD is parallel because we proved it as a parallelogram. AD is parallel to BC and DC. See here, AD is parallel to BC and CD is a transversal, and CD or DC is a transversal. Therefore, angle C plus angle D is equals to 180 degree. Just now we proved that angle C and angle D are equal. So therefore 2D is equals to 180 degree, 2 ones are 290. So we got angle D as 90 degree, and we proved angle C and angle D are equal, so it is also 90 degree. We proved it is a parallelogram, so angle D is equals to angle B, it is also 90 degree, and angle C is opposite to angle A, it is also 90 degree. You write there. In equation 2, we have angle A is equals to angle B is equals to angle C. So angle A is equals to angle B is equals to angle C is equals to angle D is equals to 90 degree. Therefore, ABCD is a square. Fine. Okay, dear students.